Now today we will discuss surface integrals. The previous one is the line integrals. In the previous one, what is the structure? So line integral with respect to arc length, line integral of vector field, and a line integral of scalar field. So same today also we will discuss same structure, surface integral over the arc length, that means double integral. Next one, surface integral of vector field, surface integral of scalar field. Okay, so same type of. So before going to the start, now first of all we will compare the single integral and double integral. I think in the previous class we have seen the comparison of the line integral, single integral and double integral, but we'll discuss again few points about the line integral, and that means single integral and double integral. Now come to the in the single integral. Single integral, single integrals. Next one, just we will compare the single and double integrals. Double integrals. Double integrals. So single integrals and double integrals. Now in the, I think in the previous class, what is the integration of a to b into 1 dx? What is the expected result? So it is the real line, and assume it is the left hand and is right hand. After integrating, what will get? The result is x. Now a to b will get the b minus a. That means here in the single integral, integral a to b 1 will get the length of the interval. Length of the interval only. Interval. Now come to the double integral. What will happen in the double integral? In the double integral, first one. So double integral. So here I am taking the region. So this is the some region, assume. Now 1 dx into dy. What is the expected result? CRs?
Area, sir.
Area of the region. Very good. So area of the region, that means the measurement of the arc. So, and I think we have seen one simple example in the previous class, but again I will read the one example. Suppose 1 to 10 and suppose 2 to 5. So I am taking a rectangular region. Rectangular region. Geometrically, what is the length? Length is 9 and height is 3. The area of the region is 3 into 9. So 27 is the area. Now calculation wise, now integral x is equal to 1 to 10 and y is equal to 2 to 5, 1 dx into dy. After doing the normal integration, x is equal to 1 to 10 and y 2 to 5 dx. That means integral 1 to 10, 5 minus 2 into dx. So 3 into x, limits 1 to 10. Now we'll get the 3 into 10 minus 1, we'll get the 3 into 9, it is the 27. That means in the first point. So in the single integral, integration of 1 will give the length of the interval, and the double integral it will give the area of the region. In the triple integral also it is given same, that means the measurement of the region. So in that the result is volume of the region. Okay, that is the comparison of the single and double integral. Okay, next one in the okay, next second one. Suppose second point, integral a to b, I am taking f of x into dx. F of x into dx. Now what is the expected result? Suppose here I am taking, suppose this is the x axis and y axis, and I am taking it is the 2 phi and 2 phi same. I am taking y is equal to x line, y is equal to x line. Now I want to find the area of this region. Area of the region. What is the area of this region? Area of the region. Area of the region. Now geometrically what is the answer? Area of this region. So we have the two regions, one is the rectangular region, another one is the triangular region. In the rectangular region, so this is the first part, the height is 2 and width is 3, that means 2 into 3, and come to the second one. So this one is the triangle, height is 3 and base is also 3, so 3 into 3 and 1 by 2, so 6 plus 9 by 2, 6 plus 9 by 2, so 12 plus 9 by 2, so 21 by 2 is the area of the region. Now so from the formula also we will solve. Integral x values are 2 to 5 and x into dx is equal to x square by 2, limits from 2 to 5, so 5 square by 2 minus 2 square by 2, so 25 minus 4 by 2 will get the 21 by 2. That means here what is the expected result? Integral a to b f of x into dx is gives the area, okay, and come to in the double integral. Same in the double integral. Now here we have the z is equal function of x comma y, and double integral of z into dx into dy is equal double integral of r function of x y z. What is the expected result? Is volume of a solid. Volume of solid. In the single integral we will get the area, and the double integral we will get the solid, okay, by taking the function. Without function it is the only length of the interval, but after taking function it is gives the area, okay. So this one is the second, okay, and we will see the one problem, one example problem in the next. Now the next one, in the last class I think we have seen, okay, no, just one more point. Now integral a to b f of x into dx, we know the total area of the region, but 1 by b minus a. So this gives the average height of the curve, average height of the curve. Similarly here, third point here. So double integral or f of x y dx into dy, dx into dy by a. So a means here the area. It is gives the average volume of solid. Okay. Anyway, this is the about the previous. Now come to the in the exactly the previous class. What is the exactly the previous class topic? Length of the arc. Length of the arc. Suppose y is equal function of x from the points x is equal to a to b. That means here this is the assume x axis or y axis and this is the x axis. This is our curve. Y is equal to f of x. Y is equal to f of x and the limits are a to b. What is the length of the arc? Length of the arc is length of arc is integral a to b under root of 1 plus dy by dx whole square into dx, or same we'll write in the second form also. That means if I can take x is equal to function of y, x is equal to function of y, and from the y limits are c to d. Same curve is same, but approach is different. I am taking the same curve, but the curve I am writing here x is equal to function of y, and I am taking here the y limit c to d. Then the length of the arc is arc is integral c to d under root of dx by dy whole square into dy. Okay, now this is the about the finding the arc length. Now come to then the double integral. So in the double integral also we have the same type of idea, but here we'll get the in the previously we'll get the length of the arc, but here we'll get the surface area. Surface area again here we have the three varieties. Suppose region is xy plane, assume xy plane, then so double integral under root of same type of structure. Here we'll take the z is equal I am taking the function of xy, so 1 plus dz by dx, that means dou z by dou x, so dz by dx whole square and dz by dy whole square into dx into dy. Similarly same, if the region suppose xz plane, then we'll take the y is equal function of, I am taking the function g function g is function of x z add, and the surface area is double integral the region r under root of 1 plus dy by dx whole square and dy by dz whole square. Here I am assuming the x and z are independent variables, so dx into dz. In the x, y, x, z plane. Similarly, suppose region is suppose y, z plane. Y, z plane. Then that means I am taking here the x is equal to function of y comma z. Then the area of the surface. So surface area is double integral under root of 1 plus dx by dy whole square plus dz by dy whole square and okay నిమిషం sir dx sorry sir again sorry so it is a dx so dx by dx by dz whole square into dy into dz. Okay, so same as the previous in the line integral that is the arc length, and we have the two varieties. In the double integral surface area, here we have the three varieties, so xy plane and xz plane and yz plane. Okay, so this one is the surface area. Now we will see one problem. So surface area, I think in the previous class also we have seen the one problem related to arc length, that is the sector problem, circle problem. Now here also we will see one problem in the surface area. Now I am asking a question, what is the surface area of the sphere? If the sphere equation is, I am taking suppose sphere equation is x square plus y square plus z square is equal to a square. What is the surface area? Surface area, anybody? Surface area చెప్పండి, speed 4 pi a square 4 pi a square అయినా 4 pi a square 4 pi a square, very good. What is the volume? Volume of the sphere 4 by 3 pi a square. Okay, now so we will solve the first problem, surface area. So we know the surface area of the sphere is 4 pi
pi a cube, sir.
Pi, sorry, 3 and sorry missing. Okay, so the surface area of the sphere is 4 pi a square. Now we will see this is the first problem. So compute the surface area okay, sigma of the sphere x square plus y square plus z square is equal to a square. So we know the answer is 4 pi a. Now we will solve by using the double integral. Okay, in the single integral it is the arc length, in the double integral surface area. So what is the formula? And again here we have the three options. We can take the xy plane or xz plane and yz plane and xz plane. So here I am taking only xy plane only. So xy plane, we have the three options. I am taking only here xy plane only. Xy plane. So xy plane means what is the formula? Double integral under root of zx whole square zy whole square into dx into dy. Or so this is the xy plane, and moreover here I am taking, so this one is assume y axis, this is the x axis, this is the assumed x axis, y axis and z axis. Okay, assume this is our sphere. So in this sphere I am taking just only half part, I am taking only half part. half part, that means hemisphere. Just I am taking the only upper of sphere, upper of sphere, upper of sphere. In the upper of sphere, the equation is, it is clearly given. What is the equation? X square plus y square plus z square is equal to a square. Now the equation is z is equal to under root of a square minus x square minus y square. Already here I'm using the xy plane. So xy planes means we have to find the dou z by dou x. What is the dou z by dou x result? Dou z by dou x. That's right, Andy. Dou z by dou x 1 by 2 of a square minus x square minus y square whole power minus 1 by 2 into minus 2x. So here we'll get the minus x by under root of a square minus x square minus y square. Similarly same dou z by dou y, because I am taking xy plane. So dou z by dou y will get the minus y by under root of a square minus x square minus y square. Okay, and what is the formula? The arc length, so surface is sigma and double integral, but we want the only half. So here I am taking the only, first of all compute only upper half. So just I am calculating only surface area of upper of sphere only, upper of sphere. Upper of sphere. So actually sigma, but 1 by 2. So we know the double integral of, what is the formula? What is our formula? So formula would ikkada derive cheddam. So the formula is under root of 1 plus z x square z y square. That means under root of 1 plus zx square. So what is the zx square? It is the x square by a square minus x square minus y square plus y square by a square minus x square minus y square. After simplification, so x square and y square will cancel. We'll get the only a by a square minus x square minus y square. That means here we'll get the a by under root of a square minus x square, will get the result. That means now this is the region or under root of 1 plus zx square plus zy square into dx into dy. Now after substituting this all, so now the double integral under root of, so under root, this result is a by under root of a square minus x square minus y square into dx into dy. Now I am asking a question, what are the x limits or what are the y limits? Here again we have the two options. You can fix the x limits or y limits, but here I am fixing the x limits. What are the x limits? X limits minus a to plus a. And what are the y limits here? Y limits here minus under root of a square minus x square and under root of a square minus x square. So these are the y limits. Now here, so the calculation of this one is that may be easy, but now we will convert into this one is in polar form. What is the polar form of this one? X is equal to r cos theta and y is equal to r sin theta, and in place of dx dy you have to substitute r d theta, And what are the r limits? R limits 0 to a because the radius is a, and theta limits is 0 to 2 pi. I think we have seen in the previous class. Okay, now substitute all this. So integral theta is equal 0 to 2 pi, and r is 0 to a, and a by under root of a square minus, it is now x square plus y square, it is now r square. So x square plus y square is equal, here we will get the r square only. So r square into r dr and d theta. Now this double integral we can split into two single integrals, integral 0 to 2 pi and d theta, and integral 0 to a by under root of a square minus r square. So sorry, here extra ar into dr. The first integration is that theta limits 0 to 2 pi. That means we will get the 2 pi minus 0. So for this first integration we will get the 2 pi. What is the second integration? In the second integration you can apply substitution method. So here the a square, okay, anyway we will solve separately, better to solve separately. Now integration of r by under root of a square minus x square dr. So the differentiation of a square minus x square is minus 2r. So minus 2r is not there. So we have to balance minus 2r by under root of a square minus r square dr. Now what is the integration of this one? So a square minus r square whole power 1 by 2 by 1 by 2. That means this 1 by 2 will cancel, minus of a square minus r square whole power 1 by 2. This is the integration of this part. Okay, now so directly here I am writing the integration of this whole part. Now integration of this one is minus a square minus r square limits 0 to a. Substitute the upper limit is a, so total 0, and the lower limit is 0. So here the minus of minus, it is the a square. But what is the result here? This one is the 1 by 2 of delta sigma. Now sigma is equal to 4 pi a square is the result. So this is the calculation of the surface area. That means the conclusion is here. Observe in the previous we have the three options. Finding the surface area we have the three options. Double integral under root of 1 plus dou z by dou x whole square plus dou z by dou y whole square. It is dou z by dou x. So dou z by dou x whole square, dou z by dou y whole square, or in the x z plane dou y by dou x whole square, dou y by dou z whole square. In the yz plane dou x by dou y whole square plus dou x by dou z whole square. We have the three varieties. So but here I am taking the only one variety. So I am giving the homework to you just to try to solve the surface area based on the xz plane and yz plane, also will get the same result. Okay, am I clear? And here I am giving the one question for you. Volume, already here I have given. Just evaluate the volume. Observe in the previous, I think yes. In the second one, in the second property, observe double integral z dx, double integral z dx dy. It is gives the volume. Now here I am giving the question, homework question, just to find the volume of the sphere. Already we know the volume of the sphere. What is the volume of the sphere? Now the double integral or z dx dy is equal double integral or f of x y dx dz, will get the value. Or you can take like this also, double integral x dy and dz, function of yz dx dy will get the value. Similarly, double integral of y dx dz is equal, you will get the double integral function of xz into dx dz, will get the value. So I am giving the homework question to you. So homework problem. So evaluate the volume of the sphere x square plus y square plus z square is equal to a square. So I am giving the hint. You can assume, okay, if you take suppose z is equal under root of a square minus x square minus y square, you have to compute this z dx dy. We will get the direct answer 4 by 3 pi a cube only. Okay. Or you can take like this also. Second one, you can take x is equal under root of a square minus y square minus z square. You have to compute double integral x into dy dz. Definitely will get the 4 by 3 pi a cube only. One more, you can try this like this also. Y is equal to under root of a square minus x square minus z square. Now we'll get the double integral y dx dz is equal 4 by 3 pi a cube only. Okay, you can try any one, but my suggestion is better to take this one. We'll get the result. Okay, like that you can easily find the volume of the sphere. Okay, am I clear?
Okay, sir.
Okay. Now this one is the about the surface area. Next one, come to our topic. So what is our topic? Surface. So this is the same as the previous one. In the previous one also, I think we have discussed line integral with respect to the length of arc length and line integral of the vector field, line integral of the scalar field. So here also same we will discuss. The first one is the first problem, first type problem. Surface, that means double integral so double integrals with respect to the surface area. Okay, in the line integral, so in the line integral of the arc length, so integral function of x y z into ds. What is the ds meaning there? Ds is equal under root of x dash square plus y dash square plus z dash square. Here also same, the double integral with respect to the surface integrals. ఒక్క నిమిషం అండి. So surface integrals, we have the again three options. The first one is double integral or function of xy into dA. So here the dA, so on the xy plane, that is under root of zx square plus zy square into dx into dy. This is the first one. And the second one is double integral function of yz dA. So the first one related to xy plane, second one related to the yz plane. Now here the dA meaning, so dA is equal under root of 1 plus gy square and gz square into dy into dz. In the first one also under root of 1 plus f, so fx whole square fy whole square into dx into dy. Similarly same third one, double integral function of xz, function of xz first xy తీసుకుందాం better, xy okay, next one xz, small change, xy, that means the function of here xz, this is the only x. So dA is equal to under root of 1 plus gx square plus gz square dx into dy. Similarly, h is function of x comma z into dA is here this one related to the yz plane, y is missing, so yz plane, yz plane. Now here the dA here, so under root of 1 plus hy square plus hz square dy into dz. Okay, now we'll discuss one problem in this double integral with respect to surface integral. The first problem is, so the first problem is here, so evaluate the integral s y into dA, and where here s is here the region or the portion, so cylinder, x is equal to 6 minus y square in the first octant bounded by so the planes x is equal to 0, y is equal to 0, z is equal to 0 and z is equal to 8. And observe here it is clearly given z values are 0 and 0 to 8. Now here I am asking a question, what is the dA here? What is the dA? Question అర్థమైందా అండి? We have the three types of problems, xy plane and xz plane and yz plane. So simply we can easily identify here the that is very simple. Here x z is equal to 0 and 8 is given. That means this problem we can solve by taking yz plane or you can take by taking xz plane also. So anyway we will try in the two ways. Okay. So first of all I will try yz plane. Now the first of all what is the equation of the, so equation So equation of the surface. So equation of surface. What is the equation of surface here? I am taking first of all yz plane. So yz plane. So yz plane means we have to separate the only x. Now x is equal to 6 minus y square. That means now it is our h function of z. That means what is the dA here? dA meaning here under root of 1 plus hy square plus h z square into dy into dz. Now simplify. Now under root of, after differentiating with respect to y, here we will get the minus 2y whole square, and after differentiating with respect to h z we will get the 0 dy into dz. That means here we will get the under root of 1 plus 4y square into dy into dz. Now this is the calculation of the dA. Now here we are taking the yz plane. So yz plane means, so the projection of, that means the projection of S on the yz plane. So anyway, so x value must be 0. X value is 0, but what is our equation? X is equal to 6 minus y square. 6 minus y square means, now after substituting we will get the 0 is equal to 6 minus y square. Now y is equal to root 6, and already it has given one of the y value, so y value 0. So finally we have y limits are 0 to 6, so root 6, and z limits are 0 to 8. Now the problem now simple. Now what is our problem? Double integral of s y dA. Now double integral, now z is equal, so 0 to 8 and y is equal to 0 to root 6, and what is our function? Y is the function, and dA is, what is the dA result? dA result is 1 plus 4y square whole power 1 by 2 into dy into dz. Now this is the now normal problem. Just do the normal integral, and luckily it is the region is the rectangular region, and we can separate the z variables and y variables just to do the normal integration. Now just to split into two single integrals. It is the first single integral, and second one y is equal to 0 to root 6 and y into 1 plus 4y square whole power 1 by 2 into dy. Now the first integration result is z limits 0 to 8, so 8 minus 0, so we will get the first integration result is 8. Now come to the second integration result, second integral. Now this problem we can solve by using the substitution method. So the derivative of this 1 plus 4 y square, what is the differentiation of 4y square is 8y. So 8y means there is no 8y, so but we have to balance the 8. So integral 0 to root 6 8y into 1 plus 4y square whole power 1 by 2 dy. Now 1 by 8. Now after substitution method we will get the 1 plus 4y square whole power 3 by 2 by 3 by 2, and limits 0 to root 6. So into 1 by 2 and 2 by 3 into 1 plus 4 y square whole power 3 by 2 limits 0 to root 6. Now 8 into 1 by 8 leave it, and 2 by 3 also separate. Then the remaining part is just now apply the upper limit. After substituting the upper limit, 1 plus 4 into 6 whole power 3 by 2 minus lower limit 0, so 1 plus 0. Now it is 25 whole power 3 by 2 minus 1. That means 5 power 3 minus 1. 5 power 3 value, what is the 5 power 3 value? 125, it is the 124. So 8 into 1 by 8. Now I am not simplifying. So 8 into 1 by 8 into 2 by 3. 8 into 1 by 8, 2 by 3 into, and 8 into 1 by 8 into 2 by 3. So this is the final result. After simplification, what is the result? So 8 will cancel, and the result is 2a48 by 3 is the result. Okay. So this is the result of this double integral by taking the yz plane. But same problem we will solve by taking the xz plane also. Now we will check. Suppose if I am taking xz plane, what is the equation? త్వరగా చెప్పాలండి equation. Just compare. Equation of the surface is, we have to separate the y. After separating the y, now x is equal to 6 minus y square. That means y square is equal to 6 minus x. Now y is equal to under root of 6 minus x. This is the function, and I am assuming this function. What is this function? I am assuming this function is function of g. Function of g. Function of g must be in terms of x and z. And what is the dA here? dA is equal to under root of 1 plus g x whole square g z whole square into dx into dz. Now just differentiate with respect to the x. After differentiating with respect to x, what is the result here? After differentiating with respect to x, what is the result? Gx is 1 by 2 6 minus x whole power minus 1 by 2 into minus 1. So here we will get the minus 1 by 2 into root 6 minus x. But we want the g square. So now the g square now here gx whole square. That means 1 by 4 into 6 minus x plus gz is 0 because it is without z. Now after simplification, okay, so this is our dA. Now next one, the projection of S on the xz plane. In this one, we have to assume y 0 because projection on the xz plane, y value 0. What is our equation? X is equal to 6 minus y square. After substituting the y value 0, we will get the x is equal to 6. That means now we have the roots. So limits are 0 to, x limits are 0 to 6, and z limits 0 to 8. Now come to the integral. Now the double integral. Okay. Now the double integral. Y dA. So here what are the x limits? So first of all, at z is equal 0 to 8, and x limits are 0 to 6, and y. What is the y here? Y into y. What is the y result? Y is equal here. Y is equal root of y is equal root of 6 minus x. So substitute y is equal root of 6 minus x into dx into dz. Sorry, and dA result. What is the dA result? The dA result is under root of 1 plus 1 by 4 6 minus x dx into dz. Now z is equal to 0 to 8 and x limits are 0 to 6 under root of 6 minus x. After simplification here we will get the under root of 24 minus 4x plus 1 by 4 into 6 minus x into dx into dz. Dx into dz. So root of 6 minus x will cancel. After cancellation, now z is 0 to 8 and x is 0 to 6. Then here we'll get the so root of 25 minus 4x by 2 into dx into dz. Now this the region is the rectangular region. Now we can divide this double integral into single integral. So z is equal 0 to 8 into dz, first integration. Now second one is x is equal 0 to 6 under root of 25 minus 4x into dx into 1 by 2. So 1 by 2 better to write outside. So 1 by 2. Now first integration is z limits 0 to 8. So 1 by 2, 8 minus 0. So first integration result is now, the first integration result is, so 1 by 2 into 8. Now come to the second integration. Now root of 25 minus 4x. By using substitution method we can solve. Now here we will get the 25 minus 4x whole power 3 by 2 by 3 by 2 by 3 by 2 and derivative of this. So derivative of this 25 minus 4x is minus 4x, sir, 4, and limits 0 to 6. So 0 to 6. So 0 to 6, then so 2 by 3 into minus 4. Now upper limit. So 25 minus 4x whole power 3 by 2 limits 0 to 6. So 2 by 3 minus 4 into upper limit is 6. That means 25 minus it is 24 whole power 3 by 2 minus lower limit 0. So 25 minus 0 whole power 3 by 2. That means 2 by 3 into minus 4 into here we get the 1 power 3 by 2 minus 25 whole power 3 by 2. That means here we'll get the 22 by 3 into minus 4, 1 minus is the 5 power 3. That means 2 by 3 into minus 4, it is minus 124 only. Now come to the first integration result. First integration is 1 by 2 into 8, 1 by 2 into 8, 1 by 2 into 8, 1 by 2 into 8. So 1 by 2 into 8. So 1 by 2 into 8. Now what is the final result? Match అవుతుందా అండి final result? Sorry, here there is a mistake. It is minus 1 by 4. So definitely we'll get the final answer is 248 by 3 only. So this 8 will cancel. This 8, 4, 2 will cancel. The result is minus or minus plus. So 248 by 3. So this is the final answer. Okay, now this one is the calculation of the surface. So double integral over the surface. So here we have the two options, but sometimes maybe some problems will get the only one option, one method, but for this problem we have the two methods. This is the first approach and this one is the second approach. So according to your convenience, you have to solve the problem by taking any one of the approach. Is it clear? Okay, Nandi?
Clear, sir.
Okay. Now I will give the homework problem to you just to practice the problem. So homework. So question is to solve చేయండి. Okay, homework problem. So evaluate the double integral x into dA, where S is the portion, cylinder, y is equal to 4 minus x square in the first octant, bounded by planes x is equal to 0, y is equal to 0 and z is equal to 0 and z is equal to 3. Okay, so this problem also we can solve by two ways, by taking the yz plane or by taking the xz plane. Okay, so try to practice the problem. Okay, so this is the surface integral with respect to the so double integral with respect to surface area. Next one, say double integral over the. So now the second type of problem. Double integral of vector field. Vector field. Now here we have the again here the three types of problems. Now the double integral is integral f dot unit normal vector into dA. Here again you have the dA is the 3. So the first one is, suppose the region is suppose projection of S on the xy plane, then dA is equal to dx by dy by mod of n cap k cap. Similarly same, this is the first one, xz plane, xz plane. Now the dA is equal to dx dz by mod of next one, third one, yz plane, dA is equal to dy dz by mod of j. Okay, this is okay. According to the projection, you have to, maybe you have the problem related to xy plane or xz plane or yz plane. If it is suppose xy plane, you have to take the dA is equal to dx into dy by mod of n dot k, that means n dot k. Next one, dA is, if it is suppose xz plane, dx into dz by mod of n dot I. If it is suppose yz plane, dA is dy into dz by mod of n dot j. Okay, now here in this we will discuss only one problem. After that we will move to the next case. Okay, సిఆర్ కంటిన్యూ చేయాలా ఆపేయాలా? ఎక్కడ సిఆర్లు ఉన్నారేమో, ఉన్నారా సిఆర్లు? హరిక, రాజేందర్, ఆల్రెడీ అయిపోయింది. ఓకే, జస్ట్ ఇదొక్క ఉంటుంది, ఇంకొకటి స్కెలార్ ఫీల్డ్, 2 ప్రాబ్లమ్స్ చెప్పేసి ఆపేస్తాం. ఓకే, సో నెక్స్ట్ క్లాస్కి ఏంటంటే డైరెక్ట్గా స్టోక్స్ థియరము, గాస్ డైవర్జెన్స్ థియరం చెప్పచ్చు. ఓకే, వింటున్నారు? 2 ప్రాబ్లమ్స్ ఉన్నాయి, 2 ప్రాబ్లమ్స్ చెప్పిన తర్వాత ఆపేస్తాం. ఓకే, నౌ ఇన్ దిస్ ఫస్ట్ ప్రాబ్లమ్ ఈజ్ evaluate f dot n dA, where f is the vector field. Now zi plus xj minus 3y square zk, and s is surface. S is the surface of the cylinder. X square plus y square is equal to 9, included in the first octant. Between z is equal to 0 to z is equal to 5. So same as the previous problem. In the previous problem also they have given z value 0 and 5 and function of x and y. Here also same. So this problem also you can solve by 2 ways, by taking the xz plane or by taking the yz plane. So anyway, so we will solve this problem in 2 ways. So here this dA you can take either xz plane or you can take yz plane, because here z values are given, z is equal 0 to 5. So that's why here I am taking either xz plane or yz plane, but anyway we will try both. So first of all I am trying xz plane. If it is xz plane, now here what is the our unit normal vector? How can find the unit normal vector? unit normal vector. What is our f? Here f is equal to x square plus y square minus 9. So for finding the n, so n is equal to, so gradient of f by its magnitude. So first of all, find the gradient of f. What is the gradient of f? Direct right chandi. So dou by dou x into I, dou by dou x I plus dou by dou y j plus dou by dou z k into x square plus y square minus 9. After simplification, we will get the 2xi plus 2yj. So this is the gradient of f, but we want the n, unit normal vector. Now the gradient of f, so gradient of f by its norm, that means 2xi plus 2yj by under root of 2x whole square plus 2y whole square. Now, so 2xi plus 2yj by, we will get the 2 under root of x square plus y square. But already we know that x square plus y square is equal to 9 is clearly given. So 2xi plus 2yj by 2 into 3. So 2 will cancel. So 1 by 3 of xi plus yj is the our normal vector. So this is the normal vector, and come to the in this one f dot n. Now the calculation of the f dot n. Now f is, what is the f? zi plus xj minus 3y square zk dot 1 by 3 of xi plus yj by, now after simplification, after doing the normal dot product of these two vectors, we will get the xz plus xy only. This is the fn. Okay, and in this one we have taken xz plane. So xz plane. So xz plane means, what is the here? The dA. So dA is equal to dx dz by n dot j. N is, what is our n? This is the n dot j. So n dot j, this is the n. So n dot j is, so dx dz by is y by 3. So this is our dA. So dA is equal to 3 by y into dx into dz. Now come to the our final double integral. So double integral on the surface f dot n dA is equal to, now the double integral, what are the x limits and y limits? Already it is clearly given y limits. ఇంకొక స్టెప్ వేద్దామండి. So y limits are, so z limits already is clearly given 0 to 5, and x limits, the function is given x square plus y square is equal to 9. So this is the circle, and in the yz plane, so y is equal to 0. So y is equal to 0 means x square is equal to 9. Now x is 3. So our x limits are 0 to 3 only. So this is the x limits. Now we have the x limits and z limits. Now simplify. Now the double integral on the surface is f dot n dA is double integral z is equal to 0 to 5 and x is equal to 0 to 3, and f dot n, what is the f dot n result? 1 by 3 of 1 by 3 of xz plus xy and dA results. So dA result is 3 by y dx into dz. So dx into dz and double integral. So z is equal to 0 to 5 and x is equal to 0 to 3. 3 cancel. Now xz by y plus x into dx into dz. But observe the double integral in terms of only x and z, but here there is a y variable. But in place of y, we can rewrite in terms of x, because x square plus y square is equal to 9. That means x z by, we will write this is under root of 9 minus x square plus x into dx into dz. Now we can do the normal integration. In the previous one, just we are splitting into the two single integrals, but here we cannot split because it is the combination. So first of all you have to evaluate the x then z, or you can evaluate the first of all z then x, that is your choice. Okay, anyway, so first of all here I am evaluating x. So first of all evaluate the x symbol. Now here z is the variable. Now z after integration. So after integration this one is 6. So 9 minus x square whole power 1 by 2 by 1 by 2, and inside here there is the derivative of minus x square is minus 1 by 2. Okay, and x will cancel, and integration of this one is x square by 2, and the limits 0 to 3 into dz. Now here the 1 by 2 cancel, we'll get the, it is the z minus z of 9 minus x square whole power 1 by 2 plus x square by 2, limits 0 to 3. Upper limit is 3 and lower limit 0. So after substituting the upper limit, this first part 0 and second is the 9 by 2, and for the second one after substituting x value 0, we'll get the minus z into 3. That means 9 power 1 by 2 plus 0. So 9 by 2 of plus, it is the 3z. It is the first integration result. Now come to the second integration. In the second integration, now z is equal to 0 to 5 into dz, and z is equal to 0 to 5 into dz, and z is equal to 0 to 5 into dz, and z is equal to 0 to 5 into dz. What we will get the result? The result is here. Okay, after integrating, so 9 by 2 into z plus 3 by 2 into z square, limits 0 to 5. Sorry. So 0 to 5. So 9 by 2 into 5 plus 3 by 2 into 5 square for upper limit. For lower limit entirely 0. In this one, 3 by 2 into 5 is common. Then the rest of 3 plus, here we'll get the 5. So 3 by 2 into 5 into 8. So 3 into 5 into 4, here we'll get the 20. So 60 is the result. Okay, so this is the first approach. Now here I am giving so this is the first approach. Now same problem we will solve in the second one also. XZ plane is over. If I can take suppose YZ plane. Now what is the expected results? So we have to take here f is equal to x square plus y square minus z. Again here you have to compute the norm unit normal vector, that is the gradient of f by its norm, and the gradient of f is same. So finally here you will get the gradient of f is gradient of f. Suppose here n is equal to 1 by 3 of xi plus y is the first one. This is the same n is equal to gradient of f by its norm. We'll get the same results. Next one, same, this fn also same, f dot n will get the same 1 by 3 of xz plus xy. But here the result will change. Here we will take, what is our assumption? I am assuming yz plane. So yz plane means we have to take dA is equal to dy by dz by n dot I. N dot I means we will get the dx, so dy dz by, here we will get the x by 3 only. That means 3 by x into dy into dz. Again same, the limits. So limits are here, z is already given 0 to 5 and we need here y limits. So x square plus y square is equal to 9. Now x0 is given, now substitute, we'll get the y value, y square is 9, now y value is 3. That means our y limits are 0 to 3 only. 0 to 3. Now our double integral on the surface is f dot n dA is. Now here we'll get the z is equal to 0 to 5 and y is equal to 0 to 3 and 1 by 3 of xz plus xy into 3 by x into dy dz. So this will get the result. Okay, and z is equal to 0 to 5 and 3 will cancel. Now y is equal to 0 to 3, z plus, so x will cancel, z plus we'll get the only y into dy into dz. Okay, so just do the normal integration, we'll get the direct result. So after doing the normal integration, so this is okay. So integral z is equal to 0 to 5 and after evaluating the first integration, now z y square by 2 limits 0 to 3 0 to 3 and upper limit is 3, that means z 3z plus 9 by 2 and lower limit 0, so entirely 0. That means 3z plus 9 by 2 is the first evaluation. Next one, think we are getting same, so 9 by 2 3z. Now the first integration, what is the first integration? Integral z is equal to 0 to 5 into dz. Integral z is equal to 0 to 5 into dz. That means already we know the result. This is the result, already we know that. So 9z by 2 plus 3 by 2 z square limits from 0 to 5. Already we have the this total result. So anyway I am writing this one again. Okay. After copy and paste. So this is the result. This result will get. Okay, so 60 is the answer. Okay, so finally here by taking the, in this problem, by taking the xz plane, this problem little bit lengthy, but by taking yz plane the problem will simple. Okay, so selecting the xz plane, yz plane and xy plane, that is your choice, but better to take the simple way. Okay, so this is the problem. Now anyway I will give the homework problem, then I will stop. ఒకటే ప్రాబ్లం ఇస్తాను, homework problem. ఎన్ని ఇవ్వాలి సిఆర్? ఒకటి ఇవ్వాలా, ఒక 4-5 ఇవ్వాలా? ఎన్ని ఇవ్వాలి సిఆర్?
More than one, sir.
మోర్ దెన్ 1, వెరీ గుడ్. అచ్చా, మోర్ దెన్ 1 అంటే 20 ఇవ్వచ్చా?
No, sir.
మోర్ దెన్ 1 అంటే 20 వస్తుంది. ఓకే, ఎఫ్ డాట్. ఓకే. Now where f is zi plus xj minus 3y square zk, and here s is the surface of the cylinder, x square plus y square is equal to 16, included in the first octant between z is equal to 0 and z is equal to 5. Okay, so here the result is, result unda leda? Okay, result is 90. This is the first problem, and the second one is, just a minute. పిల్లలు చెల్లలు ఆన్సర్ వచ్చిందా అండి? ఎవరో now the second problem, this is the first problem, and second problem, f is equal yzi plus 2y square j plus xz square k, and s is the surface of the cylinder, x square plus y square is equal to 9, contained in the first octant z is equal to 0 to 2. Okay, and next to third problem, f is equal 12x square yi minus 3yzj plus 2zk, and the surface is, s is the portion of plane x plus y plus z is equal to 1, includes that in the first octant. Okay, here a z is 0 to 1, and b y is equal to 0 to 1. Try to solve the problems. First octant. Next one, fourth problem. Sarpathas here, fourth problem. Solve. If f is equal to 6zi, 6j plus 3yk, and S is the portion of the plane 2x plus 3y plus 4z is equal to 12, which is in the first octant. Okay, so try to solve these problems. Okay, so anyway I will stop now. Okay.